Welcome to the session. In this session, we will derive simulation model of DC motor. So we have discussed about the mathematical model of DC motor. This is the image of the block diagram that we conclude at the last. So we are having the DC motor parameters for the 5 HP DC motor. So this 5 HP power DC motor has its resistance, inductance, inertia, viscous friction, this voltage across armature, so rated voltage of armature, rated field voltage and rated speed are given. So we will model this DC motor from the mathematical equation that we already derived, and in the block diagram form it gives the more clear idea about how we can simulate and build the Simulink model in the Simulink library. So we will start with the summing point, then gain, and then equation, transfer function. So this only 3 blocks we require: summing point, transfer function and gain, and we will connect according to requirement. So first we will take the summing point. So from the Simulink library commonly used block we can find the summing point, and one is plus sign, one is minus sign required, so I make it minus. And then we will require the transfer function from voltage to current. So we will take the transfer function from the continuous transfer function, and we will set the values also. L and RA values are known, so I will put the parameters. So in the denominator, the first we will put the L, so it will become Ls plus R. So value of L is given 0.028 Henry, and value of resistance R is 2.581. So you can see it's clearly visible. It is connected. The transfer function is voltage to current, so I will change the name it voltage to current. Now we require the gain. So again I will go in commonly used block under the Simulink library, and I will take the gain block. So gain represent the constant KT. So KT is not given. We will see how to find the constant KT. At present keep it as it is 1. I am writing constant KT. Then again one more summing point, so I will right click and drag it. It is connected. Minus torque, so I will take the constant that we required for the input also, and 1 for the load torque also. Sign is negative. So this is our supply voltage, armature voltage, and this is load torque TL opposing, and one more transfer function is required for the mechanical system, and I will change the parameter J S plus B. Value of J is given, inertia is 0.0215 kg/m², and viscous friction of bearing with the oil lubricant very less, 0.03. You know about the 3 frictions: static friction, viscous friction and Coulomb friction, right? So we have considered only the viscous friction, and we will use the scope for the monitoring. So first I will use the scope and connect it, right? So we require one more gain, so I will right click and drag it. So rotate the block and name it KB. You can rotate the block with the control R2. Press the control, select and press the control R. And this is, so here it is back EMF, here it is speed in radian per second, this is voltage, this is V minus EB, this is current, and this is torque. So our mathematical model and simulation model look same. So simulation model is ready and it's developed, and only thing is we need to find the KT and KB. The value of constant KT and KB still we have to find. Supply voltage, we can supply the 240 volt, we'll see it later, but first find the. So now I am deleting this image. This is just image I have taken from the presentation, and let's now it's visible.